Hi, good morning. Good morning, Professor. So we are from Project 3 and we chosen this project as building web applications for analyzing and presenting complex scientific data. So let me explain about this. Before that, I need to introduce my teammates. I'm the project manager for this project and Neha Reddy Attapura. She's the data scientist. Srijana Potnath, she's a user interface developer. Vaibhav Bomadi, he's the technical lead for this project. Pragati Patuka, she's the risk manager, and the Pujita Gangarapu, front-end developer. Firstly, I need to mention thank you for everyone to be such a huge part for this project. And coming Yeah, coming to the introduction, we did so much research on the project. So we chosen this project because our team was very passionate about the web development and the technologies used in this project. So this project mainly focuses on developing the web-based applications, which helps the user to visualize the complex data in some a simple manner. For example, I can say that healthcare, climatic research, and some space exploration and some environmental monitoring systems. So, when we compare these domains will generate a huge volume of complex data and making some, they need some requirement in the visualization and data analysis tools. So, this project is exactly aligned with the same manner. So this is a very user-friendly manner where we have used Tableau and the Power BI in order to display the data into some graphical representation. And also the main thing, the main features in this project is we need to keep the CSV format as the data and we need to upload it and it will process the data and it will give us some graphical representation where the customer can know what's going on and what's the output of this project and he can know without any technical knowledge even. So coming to the business objectives, here I mentioned the 3 points, which is very important for this project. So first one is the cost and the time. These two plays a very important role in everyone's life. So when we are using these visualization tools, the time taking for the output or for the data representation is very less, and even the cost will be the less. So this is one of the advantage. And second one is the user friendly interface, so that the non-technical person or the person who don't have any idea on this type of tools or any other, so they can use these type of tools and they'll get to know what's going on. And third one is the improving the data analysis capabilities will be the more, because we are using some different types of tools and advanced technologies and the framework which is used in Java.
Hi, now let's look at the project milestone, which outlines the major phases and tasks we have structured in this project. We begin with planning and requirements, where we define the overall scope of the project, gather detailed requirements from users, identify our technology stack, and create a project timeline. Then we move into the user design stage. Here we focus on wireframing and prototyping, the user interface, followed by visual design and user experience testing. Next is front end development, which involves selecting a framework. Following that, we have back end development. Once both the front end and back end were ready, we moved on to the testing. Finally, we reached the deployment and maintenance stage. So, in the slide, we listed the key constraints. One major constraint is the dependency on external suppliers. In certain cases, we rely on third party providers for resources or services, so which could lead to unexpected delays. Another limitation is technology related. Both hardware and software can pose challenges. especially when integrating with advanced scientific data systems. So each department is expected to complete tasks within a limited time frame, which puts pressure on delivery and quality. Recognizing these constraints early help us plan better and anticipate risks. On the other hand, our project is built on a few important assumptions. We assume that we have access to updated scientific data and resources which are critical for accurate analysis. An adequate budget has been allocated for the entire project, so financial limitations won't hinder our progress. So lastly, we are assuming that there is proper compliance with data security and protocols, algorithm standards, which is crucial when dealing with sensitive scientific data. So these assumptions guide our planning and help us set realistic expectations.
This slide presents the work breakdown structure, which outlines the major phases of our project life cycle. We begin with planning and requirements gathering, defining the project scope, collecting necessary inputs, and identifying the right technology stats. This is following by UI UX designs, where we create wireframes and test user flows. Then comes front-end development using modern frameworks like React and Angular to build the interface. Back-end development focuses on setting up servers, APIs, and ensure security. Testing ensures systems reliability through unit and integration testing, ending with user acceptance testing finally. And finally, deployment includes launching the applications and ongoing maintenance like bugs, fixes, and performance monitoring. On this slide, we highlight the budget planning for the entire project. It covers resources allocation, tool license, inf- uh, infrastructure cost, and labor. Careful budgeting ensures that every phase from design to development is funded without overspending. This helps maintain financial efficiency and keep us aligned with our cost reduction goals while ensuring quality and reliability in development.
Now, I'll explain our Gantt chart with critical path, which outlines the full timeline and task structure of our project. So the Gantt chart breaks the project into six main phases. They are planning and requirement, UI/UX design, front-end development, back-end development, testing, deployment, and maintenance. Each phase contains some specific tasks. For example, in planning, we define the project scope, gather requirements, select the technology stack, and create a timeline. Same as in the design phase, also same. We move to wireframing, UI design, and US testing. So each task is shown as a horizontal bar across a timeline representing its start and end date. Some tasks can overlap, whereas some tasks can run in the parallel way also, such as backend and front-end development. While others have dependencies, meaning like one task must finish before starting the other task. The most important part of this chart is critical path, which we have highlighted already. These are the tasks that must be completed on time because to stay the project on schedule. For example, like tasks like defining the scope, UI design, developing key components, user acceptance testing, and final deployment. These are all on one path, like all are on the path. If any one of them are delayed, the entire project timeline shifts and sometimes it may delay also. So, task not on the critical path has have some flexibility called slack time, which gives us room to adjust them without affecting the overall delivery. So finally, the entire Gantt chart helps us to manage time, resources, priorities effectively. It's a visual tool to monitor progress, avoid bottlenecks, and ensure critical activities receive the attention they need to keep the project on track. Thank you.
Here, we focus on the structure of our transition team and the role of subcontractors. The transition team is responsible for ensuring a smooth shift from development to operational use. This includes financial development, documentation delivery, and user onboarding. Subcontractors plays a positive, supportive role where specialized tasks like hosting services and security audits or third-party analytical tools are outsourced to expert vendors. This hybrid structure ensures that the core team remains focused on development while uh, trusted subcontractors support their needed, making the transition seamless and effectiveness.
So, in terms of subcontracts, a project may involve engaging with third party vendors for specific services or expertise that are not available in house. So, this could include support from certain technologies or additional development assistance and design enhancements. So, we have the front end development team and the experts in data processing. So, the first front end development team were we were responsible in updating the visualization framework, which along with the user interface improvements and updates, and the experts in data processing, they were ensuring the proper mitigation and migration in the data structures that has been approached in the project. Hi, so the measurable organization value, in that the data valuation and implementation is like 90% accurate because we have recorded the data accuracy, which was like 90% accurate, and then the page load time was like less than 4 seconds, so which denotes the optimization and the performance of the project.
This final slide highlights how the project delivers measurable value and how it has been accepted. During testing, the system's performance was evaluated for speed, reliability, and scalability. Cross browsers compatible tests were successful and beta testing provided valuable user feedback. Based on this feedback, we were made to align the products and stakeholders' expectations. The application meets the quality assurance standards and processes scientific data with minimal errors. The transition to operate includes detailed documentation, deployment in the lightweight production environment, and a complete operational guide. This ensures smooth handover to the support team and long term sustainable to the platform.